Welcome to the video on scatterplots. Let me get the title up on the board here. Scatterplots. Also referred to as scattergrams. So we can put here kind of AKA scattergram. Most of your statistical software will actually talk about these as scatterplots though. And so what I've done is, in this example, I've created the data set in an Excel file and imported it in here to our Blackboard setting. And this is the data. This top data set here. We'll call this data set A, and we'll call this data set B down here. Data set A is right out of the text on page 266, and I thought we would just go through this as an example together and go over the graphing technique of what the scatter plot is and give you an intuition of how to kind of interpret these scatter plots or scattergrams. And so what you see here is you see person A through H, so 1, 2, 3, 4, 5, 6, 7, 8 cases here, and in each case of or individual or person we have measured or observe the number of sit-ups that they can do and the number of push-ups they can do. So the number of sit-ups is frequency, it's a continuous variable, and we can kind of consider this sit-ups to be, we're going to plot this on the x-axis. Well, let me try something that's going to show up a little bit better here. We're going to call this our x here, and our push-ups we're going to, which is also a continuous variable and frequency counts here, we're going to measure it on the, or plot it on the y-axis. So sit-ups is going to be our x-axis, push-ups are going to be our y-axis. So let me get a set of axes up here for us. So here's our y. Here's our x. Okay, so here we go. Here's our set of axes here. So what do we want to do? We want to look at these as kind of a Cartesian graph space here, and we're going to have kind of xy coordinates that we're going to be plotting. So for person A, well, let's get our graduations here. So if we look at the variable x, sit-ups, our highest value here is 16. So let's count this off by twos. So 2, 4, 6, 8, 10, 12, 14, 16, and even though we don't have a number above 16, we'll take it up to 18. So then push-ups on the Y, we don't have anything over 10. So again, if we count off, well, here we could probably count off by ones if we needed to. 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll call this up here 10. Okay, so let's plot these coordinates here. So for person A, we have 15 sit-ups. So we'll go over to approximately 15 here on the x, and we're going to go up to 10. So we're going to be approximately right here with person, and I'm just going to, well, I'm not going to identify these yet. You'll see because we're going to put a line of best fit in here. So that's person A. Let's get person B on here. They did 5 sit-ups and 2 push-ups. So it's going to put us approximately right there. 11, person C did 11 sit-ups and 5 push-ups. Should put us just about right there. Person D did 10 sit-ups and 6 push-ups, so 10 and 6 puts us just about right there. Person E gave us 14 sit-ups and 7 push-ups. So it puts us just about right there. F gave us 3 push-ups, or 3 sit-ups that is, and 1 push-up. Last two, person G gave us 16 and 9. And then person H gave us 8 sit-ups and 5 push-ups. So it might have been easier to write sit-ups here, push-ups here. Okay, so this is a scatter plot. You're just taking a continuous variable, x over here, with a continuous variable y over here, and plotting their respective coordinates. So for each person, what's important for you to note here is for each person, you have a matched x and y data point for them. You can't do a scatter plot, or going on to correlation, you can't do correlation unless you have 2 measures, 2 continuous measures on them, an x measure and a y measure for the same person. Okay, so taking the scattergram kind of, and looking at it to kind of interpret it and give us a sense of intuition here, you can see that all of these cases are almost forming a straight line. In fact, if we put a line of best fit in here, and we'll make this blue, and I'm not going to be able to do a great job with this. Let's see, but if we kind of very difficult to kind of do this, but that might be a line of best fit right there. So not all of the points here, or coordinates, fall directly on the line. But what is a line of best fit? A line of best fit, is really a trend line of the data, of these data points, where this line represents the point at which all the deviations from the line would equal 0. So let's just think about that for a minute. So let's just take this point right here. It has this distance away from the line. Okay, so this distance right here. And let's just take this point. It has this amount of distance from the line right here. And so this blue line represents there's going to be a certain number. If you were to sum, let's just back up for a minute. If you were to sum all the points above the line and their amount of distance vertically above the line, and you were to add it to the sum of all the points below this line, they would equal 0. So a line of best fit is the point where all points that deviate from it, both above and below the line, would sum to 0. Very similar to the concept of the mean, where all deviations from it above and below, because it's the balance point, it's that measure of central tendency, would sum to 0. So this is the line of best fit, and this line is going to have a slope to it. So if you can remember the concept of slope, it's the change in y over the change in x. So you're going to take a any y value over here. Let's just say you took y equals 8, and that was your y2, and you took your 8 minus 4, and so this was your y1. So if you did y2 minus y1 over, and then take your x2, whatever this comes down to over here, if this was your x2, you take x2 minus whatever this corresponded to in terms of your x1, and this would give you some value here, and this value is the slope, and that slope is going to be important to us when we're looking at the correlation. So we're just trying to lay the groundwork and the intuition, but let's just go back to how these things are scattered. You notice that they're forming really closely to a straight line, and so we would kind of consider this relationship between push-ups and sit-ups, given the data set in A, to be kind of linear. They're following very closely to a line going from the bottom left to the upper right. We'll talk about what that means in another video, but let me contrast that with another scatter plot. So let's look at data set B. Now in data set B, I have altered the data. Let me get a set of axes here. So we've got X, we've got Y, we've still got push-ups, we've still got sit-ups down here. And so from a sit-up standpoint now, we're still going out to about 16, so let me count this off by 2s again. So 2, 4, 6, 8, 10 is going to be messy there, 12, 14, 16, 18. And my highest on the push-ups is still, well, it's gone up to 12 now. So we'll count this off by 2s now. So 2, 4, 6, 8, 10, 12, 14. Alright, so let's just plot this set real quick. So person A, they did 4 sit-ups and 10 push-ups. So 4 and 10, approximately right there. So person B, 5 and 2. Person C, 11 and 12. Okay, 11 and 12, approximately right there. D, 10 and 6. E, 6 and 7. F, 3 and 1. G, 16 and 2. H, 14 and 4. Alright, so we've drastically altered the data here. So now you'll see this concept of line of best fit kind of maybe a little bit more clearly. We've got to draw a line through this such that all of the values above it would equal all the values below it. So this might look something a little more like, I don't know, maybe something that kind of, well, that's a little bit too much. Something that looked a little more like this, where now this vertical distance from the line and this vertical distance from the line, if you were to sum it, would cancel out this vertical distance from the line and this vertical distance from the line, and so on and so forth. So this is certainly much more scattered, not a very strong relationship, at least in terms of being close to this line. So if you were to kind of look at this, and I'll kind of use a different color here, these are grouped nicely in kind of an oval pattern here, where this one is much more of kind of a big circular pattern. So being able to graph these scatter plots and look at them can give you a lot of information about how the relationship might be functioning between these two continuous variables. With the data set A, we're seeing here that there is some kind of relationship that as you increase in an X value, you're kind of increasing in a Y value, but not the case in data set B, where there is no, you could be decreasing. You know, if you're going up in sit-ups, you could be decreasing in push-ups. If you're going up in push-ups, you might be going up or going down in sit-ups. There's just really no relationship between these variables, which is why they're kind of plotted on a scatter plot in kind of this large dispersed circle. So hopefully that gives you a sort of intuition about what a scatter plot is and then how you can kind of interpret it. Let me just briefly, before we kind of put this away here, that if you were to plot this and say an Excel spreadsheet and then paste this, see if I can bring it in here real quick, this is what it would kind of look like. This is what it would kind of look like right here. And again, you know, we've kind of drawn this in this particular fashion up here with, this is representing, this graph here now is representing data from data set A up here, so we'll just label this quickly. This is the actual data points from data set A. Okay. And again, the same thing is true here. It's just that all of these little, you know, let me switch to red here. All of these distances between the line and these points above and below would cancel each other out. And that's what this dotted line represents, the line of best fit. And that line has a slope to it. And that slope is going to be important to us in terms of correlation. So again, I hope this gives you a general sense of the scatter plot, how to use it, and how to interpret it. Thanks for watching the video.